to give you audio. You can hear me, so you'll probably hear him. He'll introduce himself starting now.
Hello, I'm Henry Strickland. My GitHub is Strick Yak, STRICKYAK, and everything I show you, you'll be able to find on GitHub. It's all open source. Okay, I'm showing a picture of a circuit board that I've built, or I had built for me, but this is a single board computer based on a Motorola 6809. Or I actually use the Hitachi second source. It's a CMOS 6309. It acts the same for our purposes. And a Raspberry Pi Pico 2. Not to be confused with a Raspberry Pi, which is like a full Unix machine. This is the Pico 2, which is a bare metal with programmable I/O. And the idea is most people who build a single board computer will have their CPU, and I kind of insist on having the vintage CPU. That's my philosophy. But they'll have a Crystal, they'll have ROM, they'll have RAM, they have various I/O devices, peripherals. I'm cheating and putting all the peripherals inside of this Raspberry Pi Pico 2 with the RP2350 processor on it. So that's providing the clock to my CPU. Looks at the address bus, sees if we're reading or writing, behaves like RAM, behaves like ROM, behaves like terminal or disk or whatever devices we want our computer to have. So the goal really is to run stuff on a genuine 6809 and cheat everywhere else. It's kind of nice because I can make these for about $15 a piece, as opposed to a lot of modern retro or $300 and up. And there's a guy who's written a fourth this year that I'm excited about, and I want to show to you today. Let's see, I want to get down here. Let's look at the assembly listing. This is an ANS compliant fourth from the standard of the year 2012 for the 1609 CPU, done this year by Sean Connor. He's got his email address in here. And I should give you the name of his GitHub. It's SPC followed by 3 digits. And we'll find that in a second. What I want to show you in here is that he's documented how his fourth words are laid out in RAM. He's documented his CPU usage. And the bit we want to pay attention to is that the 6809 famously has 2 stack pointers. There's S and there's U. We're going to use S for the return stack. We're going to use U for the data stack. There's an index register Y, which is going to be the instruction pointer in fourth. And then D and X are used kind of as scratch or as the guts of the fourth word. And then this goes on. And I'm going to show you one more thing while we're in here. Let me search for, okay, I'm not finding it. I'll show it to you later. Quit this. And change to this shell. This one, here we go. So I'm going to run my make. And what this is going to do is it's going to launch my circuit board with the 6809 on it. And got to restart one more time. Plug in the circuit board, and the USB device shows up. And the firmware on that board starts typing this punctuation, dot, colon, comma, semicolon. That's kind of its prompt to say, I'm here and I'm running. And my terminal program saw that it was up and running and loaded in the version of fourth. And I'm going to type C3 to actually launch it. And we can demo to you now that it actually works. Let's say 6, 7, multiply dot. Yay, we can define things like define square to be dupe and multiply. So what is 8 squared print? and define count to be 0, starting at 0, do, print I, and loop, and 99, count. So we have a working version of fourth. And let's print the words finally. So that's all the stuff that has been defined. So I think it's kind of cool that it's compliant, that he's been able to run the tests and all. But the final thing I'm going to show you, and I think like Dr. Ting would have liked this. You know, he liked making processors out of FPGAs and things. I'm using this Raspberry Pi Pico with its programmable I/O to operate on an 8-bit bus, pretend like it's a bunch of 8-bit devices, which I think is kind of cool. And since I'm doing that, it can also be logging instructions that are going on for debugging. So I'm going to start it all again, plug in my 1609 card. It's going to load forth into it. And this time, I'm going to type CE8, which is going to run slowly, but have a lot of debugging going on. So I get my OK prompt. Let's do something really simple like print 6. It's going to take a few seconds. This was instantaneous before. Well, oh, it printed it pretty quickly. I hope we're still working. Let's see. Now I get my log file. And look for cycles like that. Oh, okay. Fortunately, I saved a log 2 earlier, which is correct. There we go. So my first cycle is this load the stack pointer with something initial and do some initializations, jump into my main, which loads a bunch of configuration for the fourth, like where's a put char routine, where's a get char routine, what do we call when we go by. And then we jump into the fourth, and the fourth runs and does all its fourth things. But I'm going to show you down around here. If I look for LDX with a comma Y, like that, every fourth word in here executes and ends with the thing that launches the next word, which is 2 instructions on this 1609 version. It's a load X from the instruction pointer, incrementing the instruction pointer, and then an indirect jump via X. And so here are 2 more instructions, which are the body of a fourth word before we get to the next, LEAX, LDX. So what's the body of this fourth word? We're loading D, the temporary register, by popping a number off of the stack and a branch not equal. So we're testing the top of the stack and doing a conditional branch. And we can look and find some more, see what's going on in this one. We're loading D indirectly using U. So this is kind of like the at operator that looks something up based on an address that's on the stack. And what we get, we store it back onto the stack. So yeah, that's exactly the, anyway, it's kind of neat that you can recognize really what's going on by looking through the cycle traces. And I've got software that lines up the address of the initial instruction with the assembly language listings, which is how I'm getting the assembly language listings along with the execution. It's joining the source code of the assembly language, which is the fourth source code, with what I see on the address bus when we start a new instruction. And that's what the ats mean, is this is the first opcode. And then you can see the other cycles, things that are pushed and pulled. So I had a couple of things to debug. There was a little nuance that wasn't quite documented rightly in this version of fourth. And I kind of debugged the problem mostly before I went to the author and asked him about it. So it's really useful to have a debug trace like that. And that's basically all I want to show. If there's any questions.
I know, could you point at your actual board
Well,
for the audience with your finger?
is there a camera?
No, the camera
around.
is taking your picture this way.
I need to quit sharing.
Want to share, that's good.
Yeah. Zoom.
Stop share.
Oh, yeah, thank you. Stop share right there. Okay. And now.
That hard to find.
Okay.
Okay, fine. Now, if I wanted one and I didn't have a soldering iron, I
Yeah.
would contact you.
So back it up.
Right.
If I did have a
Okay.
soldering. I'd contact
Don't, yeah,
somebody
there
that
you
would
go.
stuff it for me and everything.
I made like 50 of these and I gave a few away to friends. And then I gave my extra stock to a guy named Rick Euland in Wisconsin, and he will sell you one. His website is Computer Connect, misspelt with only one N in the word connect.
Okay, if you're interested in
Or-
having one,
Yeah,
talk to Strick.
yeah. Or
His-
there's a guy in England who just took my GitHub and took the Gerbers and had JLC-PCB make him 5 and send them straight to him, and he did his own.
could
So you
take
can do it that way.
Maybe a couple pictures of that, and email them to me so that we can have them on
Yeah.
the website with
Yeah.
the news of your great presentation.
Yeah.
Thank you so much.
And this might even be the solution to Chuck's problem.
No.
You know, in a 64K memory space, how much complexity can there be? And if you can run a 4th in it, he can do what he wants.
Great. On with the show. Thank you so much. If you have
That's
any
pretty
questions, you can forward them to Strick and maybe drag him back here for an expanded talk. I want more,
Okay.
but that's just me.
What's the power source on that?
The rule is.
So USB connection to PC. Yes.
You know who's next, so on with the show.
East.
So it's built into the Pi Pico. It rectifies out 5 volts and 3